Okay, so we are going to take a look at another way of solving a system of equations. And today we're going to look at solving them by something called elimination. So I want you to take a second to copy down all this stuff up here. Those are our steps that we're going to go about to solve a system like this. So pause the video for a second and write all that down, and then they'll make a little bit more sense once we actually start doing them. Okay. So the first one I want to look at with you is this first one right here, number 1. The first step that we wrote down up here was to make sure that your equations are lined up. What that means is that all of my variables are in the same place in both equations. This one, that's already done for us. My y's are lined up with each other, and my x's are lined up with each other, and you also want your constants hanging out at the end like that to be lined up with each other too. So we did step 1 for number 1. The second one says add or subtract equations to eliminate the variable. Look for common coefficients. Remember when we were doing this by substitution, the whole point was to get an equation where I only had one variable because that makes it easier for me to solve. I'm doing the same thing here, but instead of substituting one thing into the other, I'm going to either subtract the equations from each other or add them so that one of the variables disappears. So for example, in number 1, if I take the second equation and I subtract that whole equation from the first one, my y's are going to disappear. So what that looks like is I'm going to take my y and subtract my y. That's going to give me a 0. I'm going to take 3x. I'm going to subtract x. That'll leave me with 2x. I'm going to take 4. I'm going to subtract the negative 2. Now, if this helps you, actually write out what each piece of this math is. If I'm taking 4 minus negative 2, that's actually going to turn into a positive 6. So I got 0 equals 2x plus 6. And now, that's an equation that I can solve. I just have one variable, so I'll take away 6 from both sides. And now I can divide by 2. And when I do that, I get that x equals negative 3. Now the second step of this is exactly what it was in my first equation, then when I was doing this by substitution. I'm just going to go back to the equations, and you can pick either one, and I'm going to plug my x in, or whatever variable it is that you find, to find what the other variable is. I'm going to pick the second equation, because it's a little bit easier math, and I'm going to say y equals, I know that x now is negative 3, and I'll do that math out, and I get that y equals negative 5. The format of my answer is the same, and that's my final answer. Now let's take a look at a couple more of these. I want you to go to our second page of notes, not that one, right here. Because remember those steps, if we go by those steps that we filled out at the very beginning, it said that I'm either going to add or subtract these equations. Remember, your goal is just to get one of the variables to disappear. So sometimes subtracting isn't what's going to make that happen. So if I look at like number 5, everything's all lined up for me. I've got my x's, y's, and number values all lined up. And I have a common coefficient, almost. The first equation has a 4 in front of my x. The second one has a negative 4. So you kind of have to decide whether you're going to add or subtract to make a coefficient disappear. Now for this one, if I take 4x and subtract 4x from it, nothing's really going to happen. I'm just going to have another messy, ugly equation to deal with. But if I add those things, a positive 4x and add a negative 4x, that's what's going to make those disappear. And then I'm going to follow suit with everything else. So I'll add this entire equation. So now this is 0 plus 16y equals 16. So then I have 16y equals 16. Divide out my 16s. and y equals 1. And now I'm going to do the exact same thing that we did before. I'm going to go back and I'll substitute into one of the other equations. I'll pick the first one because everything's positive and I don't want to deal with negatives right now. So now I've got 4x plus 9 times 1 equals 5. 4x plus 9 equals 5. Subtract 9 on both sides. 4x equals negative 4. Divide by 4, and x will be negative 1. So then your answer is negative 1, 4. Now I'm going to do a couple more of these with you just so we're seeing a couple different types of problems. That was I just showed you a subtraction and addition one. Now let's scroll down here and I want to take a look at number 10, 11, and 12. Now number 10, I'm not actually going to do the whole thing with you, but I want to get you started on it because the first step back here in our notes said make sure the equations are lined up. All the ones that we've looked at so far, they have been. But if you look at number 10, that's not quite the case. Oops. Looking at this, I have y's on top of x's and an equal sign in the middle. Before you can start subtracting stuff, you want to rearrange this so that they both look like each other. And all that's really nothing new for us. We're just going to move some stuff around. So like, for example, this first equation, I'm going to subtract 2x on both sides to make it look like that. And now I've actually got something that I can use, that I can subtract from each other. So like I said, I'm not going to finish that one with you. I just wanted to show you one that I needed to rearrange some stuff for, but I do want to do 11 and 12 with you. So number 11 and 12, both of those are kind of nicely set up in that I don't really have to move anything around. I got some matching coefficients. So let's start with number 11. And let's pick the x's to eliminate. Now, I've got positive x for both of them. A positive 3x, sorry. So what I want to do there is I want to subtract. That's what's going to make my x's disappear. When I do that, I'm going to have 0 there. And then again, I'm going to do, if it helps you do that math out, write that math out to figure out what you're actually going to get. What's weird about this one is the y's also disappear. And then on the other side, I have negative 10 minus negative 13, which is going to be 3. So the math that I've got is 0 equals 3. Just like we saw with our substitution and in any multi-step equation that we're solving, if I get something like this, something that doesn't make sense, that's not a true statement, I have no solution. Now let's take a look at number 12, because that one's also going to give us kind of a funky solution. Again, notice that things are very much the same in all of these. I've got the same coefficients with just different signs. So let's do the same thing. Well, actually, let's get the y's to disappear this time. So if I've got a positive y and a negative y, I want to add these two to make them go away. So that's going to give me 0 there. But kind of like what happened in number 11, when I add up those x's, that's also going to give me a 0. And then when I add up the numbers on the other side, that's also 0. So now I've got 0 equals 0. That is a true statement. And in those cases, we said we had infinite solutions. Okay, so let's look at one more thing. this third page notes asks you a question at the top, and it says, what do you do if there's no matching coefficient? So what we're doing in this case, now we've just been kind of doing operations between these two equations, subtracting them from each other, adding them to each other. I can also multiply either of these by any number that I really want to kind of change what they look like. So my answer for this is I'm going to multiply one or both equations by some number to create matching or opposite coefficients. Okay, so if you got to, pause the video for a second so you can get that down. I just want to do number one with you, and then you're going to do a bunch of practice on your own. What I mean by this up here is if I look at number one, notice none of the coefficients match nicely like they did in the first one. I've got a 1 here, a 3 here, a 2 here. None of them match up. So I want to multiply so that they will. So for example, I'm going to choose to multiply this first equation by a -2. And when I say multiply the equation by a -2, I mean the whole thing. So you're basically doing the distributive property on this equation now. And now that equation becomes -2x minus 6y equals -12. And then I'll put my second equation down underneath it. So notice now it looks a little bit more like the first set of problems that we were doing, where I've got nicely matched coefficients, and now I can add, subtract, or whatever it is that you want to do. In this case, I want to add, because if I have -2x, I want to add a positive 2x to that in order to make them cancel out. So that'll give me 0 for my x's. -6y plus -7y gives me -13y. And then -12 plus a -1 is going to give me a -13. So then what I've got is -13y equals -13. Divide out my -13, and I've got y equals 1. And now I'm going to go back and substitute into my original equation. I'll pick the first one because that one's a little bit easier. But instead of saying x plus 3y, I'll say x plus 3 times 1. That should be a positive 3, my bad. And then x equals 3. And then your answer is 3, 1. So you guys are going to practice these by finishing all the rest on all these notes. And again, all of these are very similar to substitution once you get past this subtraction part. So I want you to finish all the rest of these on these first two and the third page, and then we'll talk about them.